Again, there's going to be a workshop on that probably in the next couple months by CARB to really dig into that in more detail. I want to talk a little bit about the laboratory inhalation studies. I think they have some utility. I mentioned earlier you have control. You know exactly what you're exposing the animals to. And there have been a number of studies of, I call it TDE, traditional diesel exhaust. This is pre-1990 diesel. It's quite a bit different than what I'll talk about later, the new technology diesel exhaust, where most of the PM is gone. But in a 6-month study that was completed by Loveless down in Albuquerque, and this is actually part of a NERC study where they're comparing a lot of different combustion sources, exposures were to whole diesel exhaust. And I want to point out that the PM is only about 1/3 of the mass. Most of them, 2/3 of that mass, are gaseous components. So, you know, any effects you see, you can't necessarily attribute to the particulate matter. As I mentioned earlier, in fact, when you filter out that particulate matter, a lot of that effects are still seen. But basically what they saw, even at very high doses, 1,000 micrograms per cubic meter, and they dropped to 300, 130, they saw only mild pulmonary and some cardiovascular effects. A lot of those were transient. Certainly didn't kill any of the animals. There was no mortality even at 1,000 micrograms per cubic meter, which is 2 or 3 orders of magnitude higher than you see in a city where the exposure is 2 to 10 micrograms per cubic meter. And I realize we don't have the quote susceptible population here, but no mortality, no real indication. And also in the NERC studies, they're comparing not just diesel, but they're comparing that with gasoline exhaust and with wood smoke, and a lot of those same mild effects are seen at similar levels. So I don't think there's any, you can attribute any unusual toxicity to diesel exhaust particles compared to other exhaust particles. If you put a particle trap on it, Jake McDonald at Loveless put a trap on a Yanmar engine and compared before and after exposure. All of even those mild effects went away when you put that particle trap on. Now the trap is a catalyzed trap. It not only removes the particles, but it actually burns the hydrocarbons. So if hydrocarbons are going down, CO is going, everything is going down with these particle traps. And then in terms of cancer, one of the reviews in the packet there, we reviewed all the studies out there. You only get lung cancer in rats at massive overload levels, greater than 1,000 micrograms per cubic meter. You get below that, there's no cancer. There's no cancer even at those massive levels in mice or hamsters either. So I think it's pretty well accepted that this overload is an unusual thing, probably doesn't get to those levels in humans, and certainly the animal evidence does not support diesel being a carcinogen. And I don't have a slide on this, but I've also reviewed the occupational studies. The trucker study is a major one, and there's a railroad study. The issue with those studies is that although they find a small increase, the odds ratio is about 1.5, maybe a 50% increase. It's consistent across all exposure levels. In fact, that same 1.5 was found in truckers before dieselization of the trucks. So I think that's pretty weak evidence there. In terms of the human volunteer studies, we reviewed about 50 of those studies that have been completed. There's little or no consistent adverse impact observed at the primary exposure levels that have been used are 100 and 300 micrograms per cubic meter. Again, those are fairly high compared to the ambient exposures of diesel exhaust, which are on the order of 2 to 10 micrograms per cubic meter. And there's some recent studies, they haven't been published, but they're certainly abstracts, where they put a particle trap on those human volunteer study exposures, and even these subtle pulmonary and cardiovascular effects that we're seeing completely disappear when they put that trap. That's Ken Donaldson's group at University of Edinburgh. Next. I want to point out that I think future studies should focus on the new technology diesel exhaust. We've done some analyses, part of the ACES study that's being overseen by Dan's group, HEI. We've got some of the data on the emissions. The emissions, when you compare to old diesel, they are actually more similar to CNG, compressed natural gas. And CARB has been involved in some studies that have corroborated that. So, final slide, just to summarize. I think epidemiology studies still have quite a few uncertainties. I'm uncomfortable about one. I know that there's a huge gamish of chemicals and potential toxins in the ambient air, and when you measure PM, that tends to oftentimes go up and down with those. Those are not being measured. We don't know. Those are unmeasurable in many studies, unmeasurable confounders. They're not even being taken into account. There's no marker for diesel exhaust in terms of going forward. Maybe we'll come up with a marker with Bart's group next month. I think some studies that do have some utility are subchronic and chronic animal studies, human volunteer studies, occupational studies in humans, and bottom line is when you get down to ambient or even occupational levels of diesel exhaust, there's not a whole lot going on. And when you compare it with other combustion sources, it's not very different from wood smoke and some of the other sources. And again, in the future, 10 years from now, most of the vehicles on the roadways here in California and throughout the U.S. are going to be new technology, diesel exhaust emitting vehicles. And these are extremely clean. There's no black soot coming out the back. You can't smell anything. It's as clean or cleaner than compressed natural gas exhaust. Thank you.
Thanks, Tom.